or identifying transformations of parent functions and algebraically and graphically, mainly graphically. All right, moving on for our first example. What is a transformation from the parent function? So we have to always think about what we did last class in the parent functions. And so I'm going to actually, first step is I would draw the parent function in. So we got to think about this parent function. What kind of parent function is this? It's U-shaped. Looking back at our notes, that's a quadratic. That's a quadratic function, also called a parabola. So I'm going to actually draw in the parent function. So 0, 0 is actually right on the edge of the coordinate plane that I have here. It's kind of the coordinate plane shifted over. The origin isn't always in the middle. We have negative 1, 1, and 1, 1 is off the graph, but it's kind of in that general location. Those are our key coordinates. So if I was to draw this graph, it kind of looks like this U. Now we're going to have to go from that parent function we just drew to the blue. So you got to think about which point is easiest for you to track that you can see from the parent function that would be easy to look at on the blue quadratic. And to me, the origin, 0, 0 here, the bottom of the U is the easiest to track, the minimum point here. So we have the minimum point. So you're looking, how does it, we got to talk about transformations, I guess. So transformations, that's left, right, up, down, reflection, and dilation. You can either make it wider or narrower. So we have, first, we go left, right, up, and down. So it's, let me stop. First, we should look at, is there a reflection? Does the quadratic go upside down? Is it reflect across the x-axis? And it does not. Otherwise, it'd be an upside down U. So the orientation, they're both U's. They would slide right over the top of each other. So then we got to talk how far left, how far right, how far up or down does it go from the parent function. So from the parent function here, we're starting at 0, 0. We go left 1, 2, 3. So that's one of our transformations. Left 3. You could say it's a translation. You could say it's slid. Left 3. Do not say over 3 though, because that over means there's no direction to over. So left 3, and then it's also going down 1, 2, 3. So it's also down 3. When it comes to left, right, up, and down, there is no order that you need to have. If there is a reflection, you should do that first. But here is, and then we're going to see if there's a dilation. So dilation would be, say, from 1, 1. That's right 1, up 1 from 0, 0. So we're looking at our graph that we're given here. Can you go right 1 and up 1, and is there another point there? Yes. And left 1, up 1, just to check. Left 1, up 1, there's another point there? Yes. So there's no dilation. Those points would be moved if there was a dilation. Example 2, what is the transformation from the parent function? Okay, from the parent function again. So always make sure you're thinking from the parent function from the very first day what we learned. And so a parent function, we got to think about what kind of parent function is this? Well, let's zoom it in. It looks like there's a starting point here. There's only one parent function that we've talked about this year that has a starting point, and that's a square root function. So, and remember, sometimes it's called a radical. So the square root function, where is that point that starting point, where is that originally? Well, it's at 0, 0. That's one of our key coordinates. And one of the other key coordinates is 1, 1. Well, you see this is at 2 here and 2. So 1's got to be just halfway in between. So 1, 1 is right here. So our parent function, I like to draw it just to kind of give me a visual on what's happening. So we're looking at going from the parent function, 0, 0, and we're going to go to that point right there. What kind of transformations need to happen? It looks like you got to go up 2 and left just 1. So left 1. Is there a dilation that's happening? Well, here's how we check that. We can just look to see from our starting point here to our other key coordinate. You go right 1, up 1. So let's look. If we go right 1 on our actual coordinate or our actual graph here, right 1, and we go up 1. No, that's a point there also. So there is no dilation here either. So this is just what we need. All right, next one. What is the transformation begin from the parent function? Always from the parent function. This is a tricky one. This is one of the more, I guess, the harder ones. So let's make sure we're concentrating on this, thinking about it. What kind of graph is this? Well, this is the only one that has 2 actual parts to the graph. And looking back at your notes, that's a rational function. So it's a rational function. And then where are our key coordinates for a rational function? Well, the parent function's at -1, -1, and 1, 1. And 1, 1's off the graph, but it's kind of over here, and that's okay. We can just draw it where it would be. And we can draw the parent function if we'd like. So it kind of looks like this and like this. So the bottom part, this bottom part, where would that go? Well, that kind of slides over this way. And where does this top part go? Slides over to the left. So on the parent function or on the graph that's given to us, it's sometimes tricky to find where this key coordinate, where does it go to? So what I would have you do is I'd look at the actual graph, one of the parts, and look where is there a nice coordinate where there's not a decimal, where it crosses over a coordinate lines. And it looks like right here at -4, -1. And on the other part, if you're following along, looks like right there's the only place where it's a nice coordinate. So I'm going to circle those. So now we're looking at what kind of transformations are happening. Well, if I'm going to the bottom left here, it goes left 1, 2, 3. And the top one, would that also work? Left 1, 2, 3. Yep, so it's a rational function and it goes left 3. That's all we need to know. All right, on our last example, we're actually going to do the opposite. So we got to read the sentence and then we need to draw the function that it wants us to draw. So it's a cubic function. So cubic function, I just kind of do a quick little draw, like what that looks like. So if we want to draw a cubic function on the actual graph, so we got our key coordinates. So a lot of times I like to draw it very visual. I'm a visual person, and a lot of people are. We need to transform it 3 units to the right. So we're going to go in the order that it tells us. So that's key. Draw in the order the sentence tells you. So always do that. Don't go in any different order. It's very important. Reflection can really mess things up. So that's why I say that. So the cubic function is transformed 3 units to the right. So I'm going to take all the points, all the 3 key coordinates, and shift them all right 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And I'm just going to do a quick draw again. And then now we need to go 4 units down. So all those where we went 3 right, we got to go 4 down. 1, 2, 3, 4. 1, 2, 3, 4. Do a quick little draw again. And now the last step is to reflect. Reflect across the x-axis. So this is the first time we've seen anything like this. So to reflect it, you got to think. A lot of times I think it helps if you think about this as paper, the coordinate plane, and you're going to like fold the whole paper on the x-axis. Where do these 3 points go? Well, they're going to go above the x-axis. So it's really just distance from the x-axis is what reflection is. So it goes down 1, 2, 3. So we got to go 3 above 1, 2, 3. The middle point here, down 1, 2, 3, 4. So we got to go up 1, 2, 3, 4. And the last point is down 5, so we go up 1, 2, 3, 4, 5. And now look at the orientation of these points. It's different. these points down here were kind of started bottom left and went top right. Now the orientation's different. So you've got to really think about this graph differently, that it's no longer starting in the bottom left and going up. When it reflects across the x-axis, it actually shifts and it goes, kind of looks like it's going the opposite way. So let me make that a little bit fatter. This is our actual graph. This is our answer. This is what we need. So the green is our best. All right, come to class with any questions. Thanks for listening.